When your engine is running, your motor oil gets hot. This leads us to the big question. Can Pennzoil Ultra Platinum even make it past 250 degrees Fahrenheit? Before we get there, we first need to know the basics. What actually happens to engine oil when it gets that hot? Engine oil is not just one thing. It is a base oil mixed with a package of additives. The base oil creates a thin film between moving metal parts so they do not grind against each other. The additives slow down damage, keep things clean, and help the oil hold its thickness at different temperatures. When the oil gets past 250 degrees Fahrenheit and stays there, a process called oxidation kicks into high gear. Oxygen in the oil starts reacting with the oil itself. That reaction creates acids, dark sludge, and sticky buildup inside your engine. The oil gets thicker in some spots and thinner in others. The additive package gets used up faster than it was designed to be. There is a simple rule that oil experts use to explain how fast this happens. For every 18 degrees the oil temperature rises past 200 degrees Fahrenheit, the oil breaks down about twice as fast. So, oil running at 236 degrees is wearing out at twice the speed of oil running at 218 degrees. Oil at 254 degrees is breaking down 4 times faster. That adds up in a hurry. An engine that spends a lot of time at high oil temperatures can have oil that acts like it has way more miles on it than it actually does. Now, before anyone thinks this only matters for race cars or big diesel trucks, what temperatures does a regular car engine actually run at day to day? During normal city and highway driving, engine oil usually stays between 195 and 220 degrees Fahrenheit. That is the sweet spot most car makers design for. At that range, a good full synthetic oil is totally fine. It is doing its job without being pushed too hard. The breakdown rate is slow. The additives have plenty of life left. Nothing to worry about. Highway driving bumps things up a little. Driving fast for a long time creates more friction inside the engine, and the oil heats up. On a long highway trip in warm weather, oil temperature often sits between 220 and 240 degrees Fahrenheit. Still okay for a full synthetic, but noticeably hotter than city driving. Towing a trailer or hauling a heavy load is a different story. Working your engine hard in hot weather can push oil temperature between 240 and 260 degrees Fahrenheit. That is right at the edge of where most synthetic oils are designed to work. Here is the part that trips people up. Your dashboard does not show you oil temperature. It shows you coolant temperature. Those two numbers are related, but they are not the same. Your temperature gauge can look completely normal while the oil in your engine is running 30 to 40 degrees hotter than you would ever guess. Turbocharged engines take this even further. The oil that cools and lubricates a turbocharger bearing gets exposed to temperatures that make everything else look mild. Turbo bearings can reach 350 to 450 degrees Fahrenheit under hard use. The oil flowing through there is the only thing keeping that spinning shaft from tearing itself apart at speeds of 100,000 to 200,000 turns per minute. After a hard drive, when you shut the engine off and the oil stops circulating, the leftover heat in the turbo bakes whatever oil is sitting in the bearing. That is what creates the crusty carbon buildup that kills turbos way earlier than they should die. So where does Pennzoil Ultra Platinum fit into all of this? And what makes it stand out from a regular synthetic? Pennzoil Ultra Platinum is made differently than most oils. Most engine oils start with crude oil pulled out of the ground and then refined to clean it up. Pennzoil Ultra Platinum starts with natural gas instead. That process creates a base oil that is far purer than what you get from refining crude. The type of base oil it produces is called a polyalpha olefin, which is a group 4 base oil. Crude-based oils, even when refined very well, carry small amounts of sulfur and other impurities that become a real problem at high temperatures. A group 4 base oil does not carry those impurities. Its structure is more even and more consistent, which means it holds together better when things get hot. There is a specific test that shows how well an oil handles extreme heat. It is called the Noack volatility test. It measures how much of the oil evaporates when it is held at a high temperature for 1 hour. This matters because when oil burns off, the lighter parts leave first. That changes the thickness of what is left behind and uses up the additive package faster. An oil that evaporates a lot during that test is one that is quietly getting thinner and weaker during every hardworking drive. Pennzoil Ultra Platinum scores well on this test, which reflects the stability of its base oil when things heat up. Another number worth knowing is the flash point. That is the temperature at which the vapor coming off the oil can catch fire. Regular petroleum-based oils typically flash somewhere between 370 degrees Fahrenheit and 410 degrees Fahrenheit. Group 4 synthetic oils generally flash at higher temperatures, often between 420 degrees Fahrenheit and 450 degrees Fahrenheit. A higher flash point means the oil is putting out less vapor at normal operating temperature. Less vapor means less oil being burned off, less buildup inside the engine from oil getting past the piston rings, and more stable thickness over the full drain interval. The additive package in Pennzoil Ultra Platinum is also built specifically to work with that Group 4 base oil. It is not a generic additive mix dropped into whatever base is available that week. The parts of the additive package that fight oxidation are matched to the demands that base oil will actually face. The cleaning agents are tuned to stop the varnish and sludge that form when oxidation happens at high temperatures. Can Pennzoil Ultra Platinum actually survive past 250 degrees? For the temperatures that a hard-working normal engine or a loaded turbocharged engine reaches, the answer is yes. The base oil chemistry and the evaporation test results both back that up. Past 275 to 300 degrees sustained, things get harder for any oil, no matter how good it is. At that point, how much of the additive package is left and how long the oil has been in the engine start to matter just as much as the brand. But the grade of oil you choose matters just as much as what brand it is. The numbers on the bottle describe two different behaviors. A 0-weight 30, for example, flows like a very thin oil when the engine is cold, which protects the engine during the first few seconds of startup before oil pressure builds. Then it acts like a 30-weight oil once things warm up. The thin cold start behavior is possible because of how pure a Group 4 base oil is. It does not get as thick in the cold as a petroleum-based oil does. The 30-weight hot behavior is what matters at 250 degrees. If the film of oil between your metal parts gets too thin at that temperature, the parts start touching. The wear that creates is slow and quiet, but it adds up. For an engine that regularly tows, runs in hot weather, or has been built up with a turbocharger making real boost, a slightly heavier grade within the range your carmaker approves makes sense. A 0-weight 40 or 5-weight 40. Full synthetic holds a stronger film at 250 degrees and above than a 30-weight in the same family. The difference is real, and it shows up in wear tests. What signs tell you that an engine's oil is regularly being pushed past where it should be? Oil that looks darker than it should when you check the dipstick before the drain interval is up is one sign. Oxidation products are dark. Oil that smells burned instead of like fresh oil is another. Check the inside of your oil filler cap. If there is thick brown or dark yellow buildup on it, that is a sign that oil vapor from heat is condensing there. A slight ticking sound on cold starts that goes away after a minute can also point to oil that has been cooked enough that the film needs time to recover at startup. None of these alone mean disaster, but seeing several of them together tells you the oil has been working harder than the drain interval is giving it credit for. So, what are the 3 things worth remembering from all of this? Normal engine oil temperature during everyday driving sits between 195 and 220 degrees Fahrenheit. That is the normal range. Towing, hot weather stop-and-go traffic, and hard driving under boost can push oil past 240 degrees Fahrenheit, and that is where the breakdown rate starts to compound. Your coolant temperature gauge will not warn you when this is happening. Pennzoil Ultra Platinum uses a Group 4 base oil made from natural gas instead of crude oil. That gives it a cleaner molecular structure that holds up better past 250 degrees Fahrenheit. The evaporation test and the flashpoint data both show a base oil that is genuinely more stable at high temperatures than petroleum-based and Group 3 synthetic blends. And the grade on the bottle is not separate from quality. Picking the right thickness for your climate and your driving habits is what allows even the best base oil to actually protect the way it is supposed to. Watch for this one pattern. If you change your oil right on schedule based on mileage, but you regularly tow or drive hard in the heat, your oil at that mileage point is in worse shape than the schedule assumes. The mileage-based schedule is built around average driving and average conditions. Heavy use and high temperatures eat through the additive package faster than miles alone predict. Cutting the drain interval shorter during hard use seasons is not being overly careful. It is matching what you are actually doing to the oil with what the chemistry inside the engine actually needs. One more thing that does not get talked about enough. Most people think oil is oil. They grab whatever is on sale, pour it in, and forget about it until the sticker on the windshield reminds them to change it. But 2 engines with the same mileage on them can be in completely different shape depending entirely on what oil went into them and how hot that oil ran. The engine that always used a quality full synthetic and stayed on top of drain intervals in tough conditions will often look almost clean inside when taken apart. The engine that ran on cheap oil through 3 hot summers of towing will show caked deposits on the pistons, sludge in the oil passages, and wear on the cam lobes that tells the whole story without anyone saying a word. The oil you choose and the grade you run are not small decisions. They are decisions that quietly determine how long the engine lasts, how well it runs 10 years from now, and how much you spend keeping it healthy. 250 degrees Fahrenheit is not just a number to talk about. It is the line where good choices and poor choices start showing their results.